Okay, let's give you guys some practice. So find the limit of this as x heads towards 0. So press pause and have a go. Okay, so to do this, break this up into two fractions. Break it up into two fractions. So break this up into two fractions. And when you're trying to find the limit of the difference of two functions, that's the same as you finding the limit of one, finding the limit of the other, and whatever the two answers are, you can just get one, take away the other. So in a way, you're actually doing this. This is one block. Find the limit of one function, and then find the limit of the other function. Whatever the two limits are, you can just get one, take away the other. So that will then take us to here. So now, hang on. Now, in a way, these two will cancel each other out. That will then give you this. Now, if you feel uncomfortable about these two cancelling out, then get a graph plotter and do this. Get a graph plotter and graph this. Sketch the graph x to the power of 7 divided by x to the power of 5. It will act as like y equals x squared. But the only difference is that dead on zero, it breaks down. So this thing here, it will act exactly the same as y equals x squared, but the only difference is that dead on zero it breaks down. That's why you've got this undefined bit here. And then if you do x to the power of 9 divided by x to the power of 6, it will act exactly the same as x to the power of 3. But the only difference is that dead on zero it breaks down. So the point here is that this thing here will act exactly the same as this. The only difference is that dead on zero it breaks down. But remember, when it comes to limits, we are always considering about where it's heading towards. We don't care about what happens dead on zero. We only care about where it's heading towards. And if you look at this here, the limit of this is exactly the same as the limit of x squared, because it's where you're heading towards. We don't care about what happens dead on zero. When it comes to limits, we only care about where it's heading towards. And then if you're trying to find the limit of this, that's the same as you finding the limit of x to the power of 3. We only care about where it's heading towards. We don't care about what happens when it's dead on zero. Well, anyway, let's go back to here. We are currently here. So in a way, these two, they cancel each other out, giving you this. And hang on. And if you sketch this graph, y equals 4x, it will look like this. A steepness of 4. Well, it's heading towards 0. So the limit of this is actually 0. So the limit of this is actually 0. Okay, and now let's go back to here. Hang on. So looking at this, so we know this is going to be 0. We know it's going to be 0. Looking at this, this is a constant. There's a limit law that says that if it's a constant, you can take it out. There's a limit law that says that if you're trying to find the limit of a function with a constant in front of it, you can actually take the constant out and then find the limit of the function itself. And then whatever the limit is, you can times it by the constant. Well, when you're here, you can actually take this 2 out here. So this whole thing will then become this. You can take the 2 out here. So now you should recognize that this block here is the number 1, because we've proved this many times in the past. So the overall answer is -2. So the limit is -2. Okay.